Good day everyone, this is teacher Justina and welcome back to my channel. And our video for today is all about factoring difference of two squares. Okay, but before that, we are going to determine which of the following number is a perfect square. Okay, so you are given these numbers and let us try see. Is 49 a perfect square? So yes, it's a perfect square and its square root is 7 because 7 squared will give you 49. Is 20 a perfect square? It's not 20 because there's no such number that we multiply by itself will result to 20 or will give you as a product of 20. So it's not. So there's no such square root, no? What about 121? Is 121 a perfect square? It's yes, because 11 is its square root. If you multiply 11 by itself, then it will gives you 121. What about 64? Is 64 a perfect square? It's a yes. And its square root is 8. And what about 24? Is 24 a perfect square? And of course, it's not because there's no such number. If you multiply it by itself, it will give you a product of 24. And then what about 169? 169 is a perfect square. It's a yes. And its square root is 13. Because 13 multiplied by itself will gives you 169. Now this time, since letter A is all a constant numbers, let's proceed to letter B. Letter B, we are to determine which of the following algebraic expression is a perfect square. What about 4x squared? Is 4x squared a perfect square? It's a yes. And what is its square root? Remember that the 4 as a constant has its square root, which is a 2. And then x squared as a literal factor, remember that if it is a literal factor, it's, it is said to be a perfect square if the exponent is exactly divisible by 2. And since x squared is divisible by 2, so therefore for x squared its square root is 2x because 2x times 2x will gives us 4x squared. What about 25 rather? 25x squared y squared. So the 25x squared y squared is a perfect square. It's a yes. And 25 as a constant, it has a 5, while the x squared and y squared has both divisible by 2. Their exponents are divisible by 2. Thus, the square root of x squared is x, while the square root of y squared is y. So therefore, the square root of 25x squared y squared is 5xy. What about 64x cubed? Is 64 a perfect square? Yes. But what about the x cubed? So 64x cubed as overall expression, is this a perfect square? It's not. Although the constant 64 is a perfect square, but the literal factor x is a factor as a variable used as a factor 3 times, and 3 times is not divisible by 2. Thus, as overall expression, 64x cubed is not a perfect square. Okay, what about 121k to the 6 y to the power of 2? Let us try investigate. The 121 has its square root, and the square root is 11. Is k to the 6? Is 6 divisible by 2? Yes, 6 divisible by 2, and then it will gives us a quotient of 3. And also y to the power of 2, still the 2 is divisible by 2. So what is its square root if this is a perfect square? So therefore 1 to 1 gives you 11 as the square root. K to the 6, 6 divided by 2, always divide it by 2 to get the square root of a variable expression. So 6 divided by 2 will gives us uh, k to the power of 3. while y squared will gives us the 2 divided by 2 will gives us a y to the 1. What about 22m to the 12 and n to the 20? Okay, so the m to the 12 and the n to the 20, they are both divisible by 2. But our constant is 22. There's no such square root of 22. Thus, overall expression, it's not a perfect square. So that's it. What about 144 d to the 8 and c to the 12? Of course, the 144 is a perfect square, while d to the 8 is exactly divisible by 2. It will gives us 8 divided by 2 will gives us a d to the 4, while c to the 12, c still the 12 is divisible by 2 and it will gives us a c to the 6. So overall expression, yes, it's a perfect square and its square root is 12d to the 4 because 8 divided by 2 will gives us 4 and 12 divided by 2 will gives us a 6. Okay, so since you are already familiar with a constant, which is a perfect square, as well as algebraic expression to be a perfect square, now this time we will be factoring the following difference of two squares. Remember that all the expressions are all perfect squares. So why they are said to be difference of two squares? And how to factor out difference of two squares. So when we say difference of two squares, as you have seen, all the operations that separates the two terms are all minus. So minus is same as difference. So where are the two squares being mentioned? So the two squares are the first perfect square in the second perfect square. So how to factor out them? Okay, first you need to have two sets, two sets of parentheses because there we will be putting all the factors. Okay, so what shall we do first? We need to get the square root of our first term. You know the square root of the x squared is x. So that's it. Okay, so we will be putting them to the two sets of parentheses that we have prepared. Next, what is our second term? It's 25. And what is its square root? The square root of 25 is 5. Thus, okay, and then, so since we need to uh, finalize them to put the sign between the first and the second term. So, what are the factors of the difference of two squares? Okay, so that's it. We will be writing them into first term being written two times. The second term, the square root of the second term, will be written also in this manner. And then we have to have a plus and a minus. Why we need to write a plus and a minus? Or remember that we are just interchanging the plus and the minus. They are just the same thing. Okay, we just come up with the same factors. I'm sorry, the same product if we will be multiplying them both. Now, question: is this always to be in this way that we need to have a plus and a minus? Yes, because if we will be putting them into same sign as we have a plus in here and a plus in here, we will not be getting the original expression that we have as our given. So again, the factor of the difference of two squares or the factors of the difference of two squares are what we called the sum and difference of two identical terms. Again, the factors of the difference of two squares, this one, difference of two squares are the sum in difference of two identical terms. So where are the two identical terms? The x and the 5. So let's proceed to number 2. So you are given the g squared minus 16k squared. Okay, having them, the two sets of parentheses, the square root of g squared is g, while the square root of 16 is 4, and then the square root of k squared is k, and that's it, and a plus and a minus. So always a plus and a minus, or we could interchange them. Number 3, the 49 is a perfect square, while the r to the 4, so its square root of the 49 r to the 4 is 7 r to the power of 2, because 49 has a square root of 7, while the r to the 4 is r squared. While the second term, the square root of c squared is c, while the square root of d to the 4 is d squared. Thus, that's it, and a plus and a minus, or that's it. While number 4, the square root of 100 is 10, and here is it, the 10. While the 6 will be divided by 2, thus it will become m to the power of 3. So therefore, the square root of 100 m to the 6 is 10m cubed. Okay, so 10m cubed. While the square root of 81 v to the 2 and t to the 10 will be 9 v t to the power of 5, because 2 divided by 2 will gives us a 1, so that is v to the 1, while 10 divided by 2, it's always be divided, the exponent of the variable should be always divided by 2, so that will be 10 to the power of 5, a plus and a minus, or like that. Let's proceed to number 5. The p to the 4, its square root is p squared, so multiplied by itself. The square root of 4 is 2, so writing them in 2 times, then the minus will gives us a plus and a minus, or that will be the other way of writing its factor. Okay, so this time, we will be getting the factors of difference of two squares, but this is now involving a fraction. Okay, so far same thing or same process. We need to separate two sets of parentheses. And so far, where did we get the 1 half x? So the 1 half x, remember that the 1/4, it's a square root. So the square root of 1 is 1, while the square root of 4 is 2. So therefore, the square root of 1/4 itself is 1 half, while the square root of x squared is x. So therefore, overall square root of our first term, which is 1/4 x squared, is 1 half x. So we are writing them in this way. While the square root of 1 is, of course, k1. And same process, we need to write a plus and a minus. Okay, so that's it. So we need not to write anymore the other way around, that we can interchange the plus and minus because it's already understood. Number 7, this time we have the 9 times the square root, 9 times x plus 1 quantity to the power of 2 minus 49 n to the 6. Okay, so therefore, we have now the two sets of bracket. And then, why I am now using a bracket? Because we'll be using a parenthesis, no, within the bracket. So again, the 9 as a constant, its square root is 3. While the x plus 1 quantity to the power of 2 as a numerical coefficient of 9, is this x plus 1 quantity to the power of 2 a perfect square? Of course, yes, because as an expression, x plus 1 to the power of 2 is a perfect square. So therefore, what is its square root? Its square root is 3 as the square root of 9, then the x plus 1. So this is a 2 divided by itself. then this will be already an imaginary one. So writing them into times. So while 49, its square root is 7. While n to the 6 will be divided by 2, then it will gives us n cubed. So 7n cubed. Okay, so 7n cubed is the square root of our second term, and a plus and a minus. While number 8, this time, we are now having both fractions in the first and in the second term. Okay, so 9 over 21. Okay, y to the 8 minus 4 over 25, c to the 6, and v to the 10. So for the square root of 9 is 3. Well, the square root of 121 is what? 11. So this itself will gives us 3 over 11, while y to the 8 will gives us y to the 4, because 8 divided by 2 is 4, and thus this is y to the 4. And for that, 3 over 11. So the 3 over 11 is the square root of 9 over 1 to 1. So let's proceed to the 4 over 25. The square root of 4 is 2. The square root of 25 is 5. So the constant, we have 2/5. Where did we get the c cube? C to the 6, its square root is c to the power of 3, because 6 divided by 2, while v to the 10 divided by the 10 will be divided by 2, will be v to the power of 5. So that's it, and a plus and a minus. Okay guys, I hope you've learned something from my video today. And if you are not yet done subscribing, please do so, and do not forget to hit the notification bell for more updates. And please leave your comments for any suggestion. Goodbye, everyone, and thank you for watching. This has been Teacher Justina, and good day, everyone.